Hey, hello, welcome back to my YouTube channel again. So in this video we're gonna cover support vector regression. So then the last video we covered polynomial linear regression, and previous to that we have covered both simple and multiple linear regression. So before starting, just a quick walkthrough that I have a GitHub here and all the codes are there. So just go to repo section, regression with Ravi, and all the notebook will be available here with all the data sets. You can download and you can do it by yourself also. And another thing, I have a Kaggle account. You can go and you can upvote it, you can like see my work so around, and I can teach you like how to put this badges in your bio too. So it's like very cool stuff. So yeah, if you like this, just go and follow me, and like I will follow you back too. Sure. So let's start back here. In support vector regression, what it does, they have sort of called hyperplane. Hyperplane is nothing but an equation of a line that is defined by y equals to wx plus b. So it's an equation of a hyperplane. So the decision boundary is decided by the level. So if the distance between them, this mean line and the hyperplane is a, so we say that both of them lies between minus a to plus a. So we sort of say here that minus a, the equation of a line, this hyperplane should between minus a to plus a. This will be the range, and all the points within that, they try to fit that model in that hyperplane. So if you want to read more, you can go to this documentation of this SVR from scikit-learn. You can learn more about this kernel. So we usually use, like, if you don't write anything, it default take RBF, but there are multiple kernels. You can try it by yourself. It's your homework. You can try and explore. So yeah, the same thing we will do. We start kernel and clear all output. So let's start with the importing all the important necessary libraries. We import numpy, pandas and everything. And the one thing important about this SVR, that it doesn't have a scalar techniques inbuilt in this model. So we sort of have to do an external standard scalar in order to like make the data comparable. Yeah, that will be the correct word. So from sklearn.svm we import this SVR model. This is the import thing important. Now we use the same dataset as we used earlier, this position salary thing. There we sort of see that there is level and this salary. So this is our dependent variable, this is our independent variable. We sort of find out at what level the person would be getting how much salary. So as you remember, for the level 6 we have like almost 150,000, like I guess it will be in dollar, I don't know in INR or what. So it's if it is 7, it's like 200,000. So again, the thing, we sort of check the null values, we splitting train and text. So the data set is too small that doing it train test bit doesn't make sense. So splitting x and y variable is the correct one. I don't know why I do so much spelling mistake. So yeah, again we sort of I have told you earlier in the video also that you can drop that thing or you can use this ialog function. So how does it work? So whatever you put after comma, it will take column number 1 and column number 2 only, like column number 1 to column number 2. But column number 2, Python start from 0 and end at n minus 1. So it will take only column 1. It won't take the second part because it will take 1 to 1 only. And here 2 means like it will take only the single value 2, second column. So the same thing we'll do here. The level 1 will be x and salary will be y. So now we sort of see the shape, what's the shape and everything. Now as I have told you that they doesn't have a scalar technique inbuilt. So we have a standard scalar. What we do, we create a standard scalar mechanism. Like this is the inbuilt, there's a module called sklearn.preprocessing import standard scalar. We create an object for that and you fit this x variable and y variable. So we assess standard scalar of x, standard scalar of y. We fit and transform them. So fit, there is three different words are there. First is fit. Fit is used when we have to use that model into the, like if you are using like linear regression, multiple regression, you just do fit. And fit transform means like it transform the data from one form to another form. So fitting the data and transforming it to another form. So new x will be the fit transform standard scalar, and the new y will be the fit transformation of the y variable. And I just did the reshape 1 minus 1 because it sometimes need np.array sort of indexing to transform it. So you can like resolve this error, it's not a very big deal. And again, as I have said you, if you don't define anything, the kernel will be default as RBF. I just wrote it for the sake. You can write it and you can ignore it too. Doesn't like, it is not a big deal. So we are now ready with our SVL model. Now what we do is we visualize the model, how sort of look like. Now you see it almost touches every point, like almost like it's very close. Okay, it's very good and very close, but it doesn't predict this last one. So yeah, if you want to see like what's the predicted value, so you remember we have used standard scalar technique to transform the data. So if we have to see the value like for level 6.5 what will be the salary, then again you have to use the inverse of transform. So you use inverse of transform. Reg is the object that we had. So what we do in regression dot predict, we'll use this predict variable, and what we will do, we will just transform this np.array of 6.5. 6.5 is the level. We will transform this value and we will predict 6.5, and then we will again inverse transpose. So because we need to see what is the value in the x in the y, right? This is the x, this x ss of x is nothing but the object when we create it for x variable. Okay, let me show you. So this is the ss of x dot fit transform, we put the value in the x. So what we do is we just predict this ss of x dot transform, we are like transforming it back, and then we are predicting it, and we are doing inverse transform so that we can see like the correct value in the y variable. So if we see for 6.5, it's showing around like 17,000 close. So if we have to go back and we have to see how much they are getting, it's like 6 for 6, it's like 150,000 or the 150,000, and for 7 it's like 200,000. So it's pretty close, you can see, right? It's like 170,000. So the model is like quite performing very well. So yeah, if you like this video, give us a thumbs up, and see you in the next video with decision tree regression model. Thank you and have a nice day. Bye.